Let's start section 5, data analysis and probability, with number 37. Here we have a bar graph, and it's showing us accidents during time slots, where our x-axis shows us the time and the y-axis shows us the number of accidents. And the question for number 37 is, most accidents occur between when? 6 and 10 a.m., 6 and 10 p.m., 2 and 6 p.m., or 2 and 6 a.m. So let's switch over to the screen, and we're going to draw all over this graph and figure it out. Alright, so here's the graph, and our option A says between 6 and 10 a.m. So here's A. Option B is 6 and 10 p.m. C is 2 and 6. And D is 2 and 6, but a.m. And they want to know, when do most accidents occur? Well, let's look at the graph. But it's certainly not D. There's no point in really breaking it down, but we're talking about 4 accidents. I guess most people are, well, if this is at work, at home, I guess the burglars are getting hurt, but A looks pretty good. It's a lot higher than D, that's for sure. Talking about maybe 17. C is definitely lower than A. I'm not even going to go the full way there. Then we get to B, and B definitely, it's right on the line. See it, we're at 18, where A is 17, so B is a pretty obvious answer there. So most accidents do occur at option B, 6 to 10 p.m. So that's really all there is to that one. The hardest part is erasing it off the screen, since it takes up so much space and it's solid. Alright, so let's move on to 38. Using the following data, we have 12, 13, 9353, and 4. Which of the following is not true? We need mode, median, mean, range. Well, first thing I'm going to do is rewrite these in ascending order, just to help me keep track of where I am, what I'm doing. And we have 3, 3, 4, 5, 9, 12, 13. Alright, so our mode is the number that repeats the most often, and that is 3. Our median, number in the middle, I'm going to cross out 2 at a time to get there a little quicker. That's 5. Our mean, we'll do that last. And our range is high minus low, 13 minus 3, which is 10. Alright, and then our mean, we're going to have 3, 6, 10, 15, 24, 36, 49, 1, 2, 3, 4, 5, 6, 7. 49 divided by 7 is 7. So let's switch back to our answers and compare what we have with what our options are. So we found that our mode is 3, so we're good to go there. A is correct, or true. The median we have for 5, and it agrees with option B of 5. We have our mean at 7, and option C is mean at 11, so that's really looking like it. If our range of 10 agrees, which it does, we're going to go with C as our option. The mean is not 11, it is 7. Alright, 39. Nope. This one doesn't look like we're going to be doing much writing, just a lot of thinking. If the data in the previous problem changed and the 9 is replaced by a 10, which of the following values would change? Well, if the 9 was replaced by a 10, well, looking here, let's zoom in on it. So the 9 is being replaced by a 10. So this is a 10 now. Well, it doesn't repeat now. There's no 10 there, so that does not change our mode. Our median, it is not 5, and it doesn't add a number to shift the median, so it's not going to be the median changing. Will the range change? Well, 10 is less than 13 and greater than 4, so it's not going to change the range. So again, our average will change. Instead of having 49 divided by 7, we're going to have 50 divided by 7, and it's going to increase the mean just a little bit. That's all there is to that question. It's another pretty easy one. Alright, let's go to 40. Al's Pizza employs 10 people, one manager for $30,000, two cooks at $20,000, two dishwashers at $5,000 each, five delivery persons at $4,000 each. If Al wants to brag about how much he pays his employees, he would use which measure? I don't understand these. The answer they give you on this test, the one that they're going to mark you right on, I'm going to go ahead and just say it's mean. And it comes out to 9,600. We're not going to do the math because I don't understand why range is an option when the range is very obviously 4,000 minus 30,000 minus 4,000 to give us 26,000. The only way I could think about it is to say they have 5 delivery people at 4,000 each. We're going to call that 20,000. Well, 30,000 minus 20,000 is still 10,000. The next closest thing we have to that is again the mean at 9,600. I'd still rather brag that I pay $10,000 on the range of my employees, even though that doesn't really tell you anything. People aren't going to think about it in depth. So if he brags about how much he wants to pay his employees to his friends, I guess the only way I can see range not being an answer is, like I just said, there's no concrete, the CEO of a company can make $130 million a year, and the part-time guy that comes in and tries to make a few sales on his spare time might make 12 grand. So yeah, that's a huge difference in range, but most people are going to know right off the bat that the range isn't really a bragging measure because it's not a measure of central tendency. And that's why I really would like if it says, if Al wants to brag about how much he pays his employees, which measure of central tendency would he use? And then we would, for those of us who know that range is not a measure of central tendency, we'll be able to rule that out. But then those of us that don't, and like I said, this test really likes to test your understanding and being able to read the problem and kind of pick up the clues in there. Well, I would have walked right in the trap of saying, well, $26,000 range is much higher than any other option, and I would have been wrong. And now we're in competency 5. That's not cool. That's a big miss, just because I didn't think of the difference between measure of central tendency and the 4 options I was giving. That being said, and that my little talk about range here, that's really the only reason I can see that they didn't choose range, because the mean really is, if I tell you what's the total number of employees he has 10 employees, and I tell you the average is 96,000 or 9,600. Well, over 10 people, if you multiply it out by 10, that's $96,000 that you're paying out on average. I don't like these questions. I wish they gave you more information. But if you do the mode, that's the one that repeats the most. That's 5 people at $4 grand each. That's nothing to, that being able to bring jobs around and stuff is something to be proud of, but it's not something you brag to your friends about if you want to go out and brag. Your median income, let's see, where does the median fall? Probably, let's see, 5.7. Yeah, it's gonna fall right in the $5,000 range. So it's better than 4,000 if you want to brag. But I'd really like to find a way to talk about my 10 employees and I pay the top guy 30 grand. I wish I had a way to just show you an equation or expression we can use to figure out what the right answer is, but I don't know. These, I really just feel like they're, hopefully you get it right. So I'm trying to talk to you through everything I see. If it said measure of central tendency on your test, do not pick range. It is not a measure of central tendency. Mean, median, and mode are. But overall, of the 3 measures of central tendency, mean does result in the highest amount. And I think that is why they end up choosing mean on the answer. If you do the math, range is 26,000. That looks the best, but it doesn't tell me enough. Mean kind of means, well, mean means on average what you're paying your employees, so I suppose that is the best way to go. Alright, let's move on to one that we can actually do some math on and feel a little bit more confident in our answer. So Bob and Carol are planning on having 3 children. What is the probability that the 3 children will all be boys? Oh, well, I will tell you that my parents ended up with 4 boys, so it's going to be even one step further than this, but let's switch over and do it. All we really need to do here is draw out a tree, and we're going to go, so here's your first child, It could be a boy, or it could be a girl. And Bob and Carol are hoping it is not a girl right off the bat because they're not going to end up with their 3 boys. After you have a boy, you're going to have your second, and I'm not going to have enough room, so, and of course I'm at the top of the page. You can have a boy or a girl here, and then here you can have a boy or a girl. Then we get into our third. We're going to move this guy straight out. So for your third round of kids, or your third child, I don't want to call them a round of kids, but we can have a boy or a girl there, a boy or a girl here, we can have a boy or a girl here. Yeah, I realized from my parents, 4 boys, that I stopped at 2 girls, so hopefully Bob and Carol's sons will figure that out. So now we're going to look only in the third set, and we're going to say you have we're going to see how many total options or the outcomes. That's the word I want. We're going to look at the number of outcomes possible here. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8 total children. So as we know from the fractions video, that is our whole. And what do we want? We want the number of boys. 3 boys. We don't want any girls. Well, how many times does that occur on our list? Here's a boy, here's a boy, here's a boy, here's a girl. So already we're not even going to continue looking at this branch. And then we're going to come to this bottom branch and see if we have the desired outcome being a possibility. No. We start off with the girl right away. So Bob and Carol's dreams are dashed before their first child is born. And we have a probability of 1 out of 8. That's an option. We're good to go. Yep, 41B, 1/8. Alright, let's see what's up next. 42. Your sock drawer is a mess and contains 10 white socks, 12 black socks, and 4 red socks. How many socks would you have to pull out of the drawer to be sure you have a pair? I don't know how to explain this one, but let me see if I can. I know the statistical point of it, or the behind it, is really n plus 1. The number of options is n. So you have 3 options here, black, white, and red. So you do n plus 1 to guarantee you have a pair. So in this case we have 3 plus 1 is 4. So you would pull out 4. That's option C. So the way it works statistically is on your first pull you'll get a white sock. Your second pull you'll get a black sock. Your third pull could be a white sock and you're done with your pair. But how many socks do you have to pull out of the drawer to be certain that you had it? Well, your third pull could be red. Well, now no matter what you pull, you will have a matching pair no matter what. So your first pull can be white, your second pull could be white, you're done. But how many do you have to pull to be sure that you have a pair? Well, 2 is not the answer, because what if you do white then black? So now we're going to look at 3 pulls. White, black, red. That didn't work, but we can do white, black, black, white, black, white. Those do work, but we haven't guaranteed that we're going to have a pull, because we've shown that white, black, and red can be pulled in 3. So if we go to 4, we can do white, black, red, and then it does not matter what our other option is or what our next color pull is. It will be one of the 3 that we've already pulled, and 4 is your answer. This is why we're in competency 5. You got to kind of think this through real quick. You have 2 minutes on these. Hopefully you've been able to bank some time, and you can use that time that you have banked to get these done. But if this is not clear, let me know. Send me an email. Write it out in the YouTube comments. Let me know, please. If you need to contact me via email, it's gkemath@gmail.com. I check it regularly. Not as regularly as I do my school email and everything else I've got going on my work email, but I will check it at least once a week, and hopefully we can kind of hold a conversation via email and get it sorted out. Alright, let's move on to 43. What is the probability that the first sock you pull out will be black and the second sock you pull out without replacing the first sock will also be black? I hope you're ready for this one. Let's switch over. Oh, my daughter grabbed my calculator earlier and I don't know where she put it. Underneath the desk. Where else would she put it? Alright. So we're going to switch over. Oh, we've already switched over to smooth draw. Sorry about that. Alright, I can hear myself again. So, the probability of the first sock you pull out being black, we have 10 white, 12 black, 4 red. So that's 22, 26 total socks in that drawer. Okay? 12 of them are black, and we're looking for black socks here. So we're going to write down, what are we going to do? We have a total of 26, so that is our whole. And now we're going to do our part. Well, the part that we're looking for, or the number we're looking for of black socks is 12. So we have a 12 and 26 chance. Remember, this is total outcomes over potential outcomes, or favorable. Sorry, it wouldn't be potential, it would be favorable. Because we could draw red, that is potential. Favorable over total possible outcomes. Now we've drawn our socks. We were fortunate enough on the first draw to draw a black sock. We did not replace the sock, of course, because we're trying to get a matching pair. What changed in our fraction here after pulling that first sock out? Both our part and our whole. I hope that makes sense. We had 26 socks. We removed one. We did not put it back in. So now we have 25 possible socks that are black, which is the outcome that we want. But we had 12 to start with, and we drew one already. So now we're down to 11 potential, or positive outcomes here. The one favorable outcomes over 25 now potential socks. So now we're going to multiply these together. And that off the top of my head, I'm not sure, 12. I have 132. I don't know why I did that in the calculator. 26 times 25 over 650. 132 over 650 is option B. Let's switch over on that really quick and just make sure that I'm not steering you the wrong way. That is number 43. B, 132 over 650. We're good. Hopefully you haven't lost faith in me yet. And let's move right on to number 44. That would be the one after 43. The Soda Shop Sunday Special offers 3 flavors of ice cream with your choice of 4 sauces and 2 toppings. How many different varieties of sundaes are available? Well, we have 3 flavors, 4 sauces, and 2 toppings. So we multiply those together, and that's it. It's the combination. 3 times 4 is 12 times 2 is 24. That is option C. So all we had to do was look at the potential choices. So we have 3 flavors, so 3 choices, 4 sauces, 4 choices, and 2 toppings. So if we take 3, 4, and 2, those are our potential choices, and multiply them together, we'll find every possible combination. 3 times 4 times 2 is 24. That's all there is to number 44. And 45. This is my favorite one. Anytime it says, in how many ways can 5 children be placed into 5 seats in the back of a van? You have 5 children, you have 5 seats. They can be placed in any combination. All we need to do is factorial it out, and that's it. So we're going to take 5 children. I'm going to switch over because I like these so much. I'm going to say we have 5 children and 5 seats. So we're going to do 5 factorial. And if you don't know what factorial means, that means you start at the highest number and you multiply down to 1. And that's it. I have it off the top of my head that 5 factorial is 120. So you have 120 possible combinations. Remember, it didn't say they couldn't repeat it. It didn't say they had a certain child in a certain seat or anything like that. You have 5 children with 5 open seats, how many possible combinations can you have? 120. I hope Bill and Carol realize that 3 factorial is still fairly large. It's enough to cause a fight. I know with 4 children and a 4 factorial possibility here with 4 seats in a car, my brothers and I love to fight. So keep that in mind. Anytime you anything, if it says if you have 20 books on the shelf, and that is a horrible number to pick for factorial. If you have 20 books on the shelf, how many ways can you rearrange them? 20 factorial is your answer. If you ever see the little exclamation point on your calculator, that is the factorial button. It'll multiply out any number you put in down times every number minus 1 until you get to 1. So let's just look at the huge difference here between 5 and 6 factorial. 6 factorial is going to be the same as 5 factorial, but with a times 6 on it. So let's just put it 6 times 5 factorial, 6 times 120. Oh, we know that that's going to be 720. So you've got another 600. You had a 1 seat in that car, and now you have another 600, arrangements to fight in. If you're not a parent yet, enjoy the peace in the car. If you are a parent and your children don't do this, send me an email and let me know what you did to bring the peace in the vehicle. That's it. That is all 45 questions of the pretest. I hope it helped. I hope you're more confident. I hope some of the problems that have scared you in the past look a little bit more doable. You have all these videos available. Stop them, pause them, solve them on your own. Come back to them. Whatever you can. We got to start passing this test on the first and second try, guys. I know this is a big scary one. I know the K through 6 is a big scary one. And I'm trying to remember the top 3 failed. It's GK Math, K through 6 content area, and I think the professional development exam, or the PED. I believe those are the top 3 failed